Hello, welcome to the Architecting Your Codebase session. My name is Kamil Szymański, and I will start without the slides, without the view on anything, because we're still waiting for the connector to connect my laptop. But I only have two slides, the slide with the topic and one with the quote. So I hope that the connector arrives on time. Because I have a live coding session, or rather live refactoring, and that would be hard without the display. So, this is an Architecting Your Codebase session, and in a minute I will explain what do I mean by that. But I want to start with saying what the session will be about and what it won't be about. Because it won't be about the latest and greatest in Spring, nor it won't be about the coolest and shiniest architecture this year, nor the new development approaches, nor the sexiest technologies available out there. It will be about things that, in my opinion, matters the most. Something I deem the most important, which is writing the code that is easy to understand and easy to change. And in my experience, this is one of the things that most of the projects that I have seen are lacking. And coming back to architecting your code base, what do I mean by that? Well, it's a term I made up. It's a term relating to my favorite definition of what software architecture is. And the definition goes like that. Software architecture is a set of answers to the questions developers may ask. So architecting your code base would be an activity of putting those answers into your source code to make those information easy to understand and easy to find. And what kind of information? Well, all the relevant ones. So for example, what business are you running in? What problem is your application solving? What technology stack are you using? What are the code conventions? How do you run this project? So all the things that you might not know should be easy to find in your source code. And we should start the live coding session right now. And I don't know what's with the display connector. So what I will be doing, I will be refactoring a Spring Pet Clinic project. Anyone familiar with it? Okay, a couple of people heard about it. Anyone looked at the source code of this project? Just a couple of hands. It's good, because if you know this project, if you know this source code, I would like you to forget everything that you know about it, because I would like you to feel the pain of exploring this project, the pain of finding out what it is it really doing, why it was written for. So I won't make it any easier for you. I won't run this project and go through the main use cases. I believe that it should be obvious from the source code, and also for presentation you want to keep it dry. Yeah, so we will be exploring the Spring Pet Clinic project, and we will be refactoring it. I will be refactoring it as soon as I get the connector. And I will be applying some refactorings there. I hope that you are familiar with the refactorings catalog. Like for the simplest ones, like rename, move, I will just use keyboard shortcuts. For other ones, I will use refactor this menu in IntelliJ. I hope you know it. I hope you use it. And what I would like you to do as soon as I start is not to pay attention, what am I doing, how am I doing it, but why am I doing things? What for am I doing it? And it's getting tricky to talk about code without showing it. But what problem we will be solving? Because if you take a look at the Spring Pet Clinic, you will have to visualize what I will be talking about. Like, you have the Spring Pet Clinic application. What is it doing? Well, from the name Spring Pet Clinic, you can tell that it's probably an application that will do something related to managing some part of some pet clinic business. Maybe it's written in Spring because it's Spring Pet Clinic. But you cannot tell, you shouldn't believe the names of the projects because sometimes they are not relevant to the code that is actually out there. So you should go deeper. So the next level would be the package structure, and your IDE is combining it with dots. So you will have something like com.spring spring framework.samples.petclinic. So it is showing you that you are going in the right direction. Like it's a pet clinic, and most probably it's written in Spring Framework. And when you go deeper, you can see what this package consists of. And it consists of another level of packages. Like you have the repository, service, model, config, util, and web packages. And you instantly know what technicalities are there. You know that this is an application written in a layered architectural style. It's a web application. And is it a problem? Well, it depends. It depends on whether, what for are you writing this application. The Spring Pet Clinic application was written to show how to use certain technologies with Spring Framework. So the packaging, like having repository, service, model, and etc. Packages is a good choice. But if you're writing a business application, well, it's not necessarily a good option. You want to show what problem are you solving, what is your domain, why are you writing this application. And if you are saying that I have just web services, repositories, and config in my application, almost every application has such packages, and it's not helpful at all. The barrier of entrance for a newcomer is really high. You cannot tell what this application is doing by just taking a look at the modules it has. So what we will be doing, we will be trying to make this barrier lower, to make this code base easier to maintain, nicer to work with, and we're still waiting. But what is the problem with having packages like service, model, repository? Well, for example, what would happen if there's a bug in that application? Like it's not able to process payments. Where do you search for this bug? Well, you have to go through almost half of the code base. You have to look into services package, into model, into web, into repositories. If you're not sure what is the place this bug resides in, you only know in what context it's present. So you have to basically go through half of your code base. If you are going to introduce some new functionality, which packages will you touch? Well, you will add it into model, into services, repository, into web. Again, half of your code base, you have to touch it. You want to touch only one context when introducing new feature, when fixing a bug, and how to, those are the basics of software design, like what rules you want to follow. You want to follow single responsibility principle, for example, high cohesion, low coupling. You want to have encapsulation. And when we think about those rules, we usually think about them at the level of classes, implementations, methods, like single responsibility principle, for example. Well, on the method level, it's super simple. It has to do one thing. On a class level, Well, it has to expose a consistent interface. And we stop at this level. But even Java has way more module layers, like you have packages, modules that can consist of packages. You can, even further up, you have applications that make up your system. So on a module level, single responsibility would be working on one context, like encapsulation. With encapsulation, we again stop with encapsulating the data. So we are hiding fields, sometimes behind the getters, which is not a real encapsulation. But we also want to encapsulate the logic, the algorithm behind it, some decisions that we made that are not important to the outside world. So we should also encapsulate those things. And high cohesion, low coupling. When we have packages like repository, service, and model, well, we have low cohesion, high coupling, because within repository package, we have all the repositories that are not connected, that don't belong to the same context. They are loosely cohesive. And the coupling between this package and the other ones, it's high because repository, it's, yeah.
Let's check if it works first.
So the repository package would be highly coupled to the services package, to the model package. So basically, we have a big model of math. You can, yes. Okay, so here are my slides. I will go through all of them. This is my favorite definition of what software architecture is. If you want to take a photo, please do, because it's a great definition. Unfortunately, I don't know who formed that definition. So if you know whom should I credit, please let me know. And let's get with the live coding part. So as I was saying, here we have, okay. Okay, we have it, although in a resolution that is not so great. And I don't have a display on my screen, so I will be turning my head a lot. So what do we have here? This is the Spring Pet Clinic application, and if you go down there, you can see, as I was saying, the org Spring Framework samples Pet Clinic package, and under this you have packages that are not telling you anything about this application. So we will start to modularize it. But in order to modularize it, we have to know what this application is doing. So we will start with learning what it is really doing. And you cannot tell from this package structure what it's doing. So we have to somehow learn it. So where should we look at to learn that stuff? My guess would be to take a look at the model and service packages. We will start with the service package because it's way smaller, and it has one service, clinic service. Is it helpful in any way? I doubt it. So let's take a look at the model. And here we have based entity and named entity, which are some kind of technical entities, so we won't deal with them at this time. Let's take a look what's also there. So we have an owner, a person, a pet, pet type, specialty, vet, vets, and visit. So probably you can see some story emerging because it's a pet clinic, so it probably allows us to book visits for vets. To book visits for vets, for pets, and those pets have owners. So we have half of the objects here covered, but there are some that we don't know what is the purpose of them. Like, for example, can you tell me what a person object represents? What is it doing here? What is its purpose? Anyone? To the vets, okay, there's one answer, but there are plenty of us here. So we can see that we have to take a look at the implementation. And how do I gain focus? So we have to take a look at the implementation. And here we have it. We even have a Java doc explaining it, and it's not helpful in any way. But we have also a mapped superclass annotation, so we can guess that it's a part of a hierarchy. And the hierarchy looks like that. We have an owner and a vet. Do those objects have something in common? I doubt it. Yeah, they have the first name and the last name fields, but this doesn't make for a proper inheritance hierarchy. Those are objects that are totally unrelated. So what we will do, we will get rid of this object that is adding unnecessary complexity into our code. So the refactor this menu. I'm losing context. Okay, the refactor this menu. I hope that you are familiar with it. So we will remove this object as soon as. So we will do the push members down refactoring, which will result in all the fields and it's super tricky to do this that way, and I'm losing the keyboard focus also. And what? Okay. So what we are doing, we are pushing down all the fields and methods. And we can hopefully remove this object that is adding unnecessary complexity to our project. Let's run the tests. And what more do we have in our model? For example, we have vets. What are vets? Yeah, you can probably guess that it's some kind of a collection of veterinarians. But what is the purpose of this object? Can anyone tell? It's hard to guess. So again, let's gain focus. And let's see the implementation. And again, we have a Java doc here, which is telling us exactly what we want to know, that it's a part of, it's doing marshalling. It's doing marshalling. So why is it inside the model? What is it doing in the domain? It should be used in where it belongs. And it's being used in one of the controllers. So let's move it there. I should search for usages, but due to the pressure of time, I will skip this part. And the last thing, what is a specialty? Can anyone tell? it should be obvious from the name of the class and from the context it's in. And right now, you cannot tell. You have to, again, take a look at the implementation, but it should be obvious from the context and the name of the class. And specialty is a specialty of veterinarians. So something that we should know of from where this class is, in which context it is, and how it's named. And we'll deal with this problem in a second. But one more thing, or two last things. Named entity and based entity. Those are technical classes. Based entity, I guess you can tell that it's responsible for holding the ID. But what about named entity? The named entity is here to just hold the name property. And again, it's part of a hierarchy. And it doesn't make for a proper hierarchy. But if you dig deeper, what it's preventing us to do is it is preventing us to name things as they should be named. Because is there something like a name of a pet type? You should have a type there. A type, a species, not a name. So again, we are adding unnecessary complexity to our project. And we are also making us unable to name things properly. So let's remove that object as well. As soon as I gain. And let's remove it. And now we have more or less a feeling what this project will be doing, but what we want to do is modularize it. And we can go discovering this project for a really long time. And we don't want to focus on doing stuff that has low return on investment. You want to focus on things that really matters because someone has to pay for this refactoring. You're not delivering new features, for example, when you are refactoring. So what we will do, we will divide our source code into parts that we want to focus on and parts that we don't want to invest much at this time. Maybe later it will be important, but right now the ROI is pretty low. So what we will do, we will, for example, move the infrastructure related stuff to the infrastructure package, and we won't deal with it right now. And what else? Well, the web, so the presentation layer. We don't want to focus on it at this time. So we will also move it to another package. I like to call this package boundary. And I also like to keep within the boundary the web part, because nowadays a lot of time you have a couple of boundaries out there. You have a web boundary, a mobile boundary, maybe a CLI boundary. So a boundary of your system that your collaborators, your end users are dealing with. And again, we won't invest much time into it right now. And what we're left with is model, repository, and service packages. And it makes for our domain. So let's move it to a domain package. And this is the place where we will put the most effort into making it as it should look like. And let's start with exposing some context from this package. So the first context that, in my opinion, is emerging here is a visit context. So we will move the visit object to its own package. Okay, you have to believe me that I will put visit there. All is it visit? Yeah. You also want to move the repository there. And you have this godlike service that knows everything about your application. And if you take a look at what it's doing, it's basically delegate to the repositories. It's not a domain or application service. It's just a plain delegate. So splitting it into services will be super simple or relatively simple. And we will do it for this. So what we want to do now is to extract a visit service. And since it's only dealing with repositories, we will just move the visit repository and methods related to it to another service. We will call it visit service. And we will put it in a visit package. So as you can see, no services, no repositories, model packages. Let's do it. And this is a tricky part without the view on my screen. So it will be a Spring service. And it won't extend from anything. And what we want here is also to inject dependencies. And since it's not Spring 4.3, we have to outwire them. And we have it extracted into its own context, but if we run tests, they will obviously fail or even won't be compiling. We have to remove, or we can remove the visit repository that is not being used here. So let's remove it. Let's also remove that. Sorry for speeding up, but yeah, we've lost a couple of minutes. And if you run the tests, it's still not compiling because you've moved the method, but you haven't said to the object using that method that they were moved. So you have to fix it. Visit service, and let's add it here. Like it. So we're injecting it into controller. And as you can probably guess, you will have the same problem within tests. Like in tests, I will do an awful thing here because of the time we have lost. I will not extract tests for visit service into its own method. I will do within this test class. Don't ever do this. I even shouldn't do that, but I want to show you the end result of this project, and I'm limited to 40 minutes. So what we will do here, we will just awfully inject a dependency to our test. But in real life, always put as much effort into your tests as you are doing for your production code. So visit service, and let's add it. Let's auto-wire it. And if we run those tests, they should fail. Hope they will. And why they will fail? Well, they will fail because they won't be able to just believe me, to bootstrap the context. And why we are unable to load the context? What we have done, we've just moved the repository to a different package. And we've done the same thing for the service. And you can probably guess it's related to some kind of component scan, but let's pretend we don't know it. Where should we look for this bug? It's a problem of infrastructure. We haven't touched anything related to our domain, to the business problem that we are trying to solve. So we can tell that it will be in the infrastructure part of our code base, and it will be inside configuration of that infrastructure. So let's take a look. It's in two places. It's enable JPA repositories, where we tell where to search for repositories. We will get rid of the repository package here because all the services and repositories are within the domain, and also it's a component scan. So again, we will get rid of this service part in component scan, and as soon as we run the test, they should pass. And we have the first context extracted, and we will do the same for the other one. Like you can probably guess it's a vet context. So let's move it into vet package, which will and let's do the same with the vet repository. And OK, I forgot about one thing. Let's get back to visit for a second. Can you see something that we can improve here? Because we've just extracted a context. And what we are doing here, we are exposing our internals, the repository, our persistent state to the outside world. It's present in a global namespace, so you can just inject it into any context. You are unable to protect any invariants. You are just telling, hey, it's what I'm using. If you want, use it as well. You can go through the services. You can do it directly. You shouldn't do that. You should do that through the guard it with your service. So we will make it package private. We can do that. And so this is the proper way to encapsulate things. It doesn't matter that we have a persistent state, some kind of repository. It can be as well in memory. You shouldn't care. You should rely on the context doing this stuff properly. So back to extracting the vet context. Well, we have extracted the model, the repository, and let's finish with extracting a service. So again, it's relatively easy because what we have here is, I'm constantly losing context. What we have here is a delegate to the database. So we will move all the vet-related methods and fields to its own service. We'll, of course, call it vet service in a vet package. Again, we will have the same issue of the project not compiling after we have done it. And we will have to do the same as we have done previously. So we'll have to fix the tests and also places where we were using this method. So let's remove this dependency from here. Let's also remove it from the constructor. And let's try to compile it. And it's failing. Here it's easier because we only have to migrate the type. So not services. But service. And okay, let's not skip this. This is equally important. And let's fix the tests. And in tests, we, of course, have to do an awful thing again due to the pressure of time. I hope it won't be recorded that I'm doing this. Let's outwire it. Let's run it, and let's take a look at our vet package. Again, we can hide our persistent state. We can guard it with service. And what we are left with is an based entity, which is a technical entity. So it's not part of the domain. So we'll move it outside of it. We'll move it to infrastructure. And we're left with 3 objects that are tightly related. If you were to look for an aggregate root, for example, that would be an owner because it has it knows about the pets it's owning. So let's. But it doesn't mean that you have to name this concept after this context after the aggregate root. We will instead name it client context because both pets and owners are clients of our pet clinic. So let's move it. Both the repositories, we can do it for repositories. And we can do the same for a service, which we will move and we will rename. Of course, we should make our repositories package scoped. Those technical issues are eating me. Okay, let's give it a second. But again, we should move. We should make our repositories hidden under the service, and let's start working. It's not Windows. I should? God forbid. Okay, let's not rename it. Let's just view it as a client service. Oh, it's renamed. Okay. So, what I also like to do is show how to run the application. And if you know web apps contain web XML when you say what is the root context, and we have it in our infrastructure, it's called root context, and we will rename it. It's Pet Clinic web app, and we will move it to the main package of our application. And we will see what we have gained with all those refactorings that we have done. So let's go from the beginning. We have our Pet Clinic application. It's probably an application for managing some aspect of a pet clinic. And if we go down there, we can see that we're on the right track. And it's a web application. Great. But what is the purpose of this application? Well, this application allows us to book visits to veterinarians for our clients. And our clients are owners and their pets. And if you take a look, for example, at the vet context, in the beginning, we had a problem to tell what the specialty is. Right now, we can exactly tell that this is the specialty of a veterinarian because of its name and the context it's put within. And the entrance barrier for such a project is really lower than from the project that we have started with. If we are to chase some bug, we know in what context it is appearing, so we know exactly where to look for it. If we are to add some functionality, just half minute. If we are to add some functionality, we know exactly into which context to add it, and if it's not part of any context, then probably it's a new one. And I haven't shown you everything that I wanted. I have it on my GitHub if you would like to take a look at it. Sorry for the technical issues. Thank you for staying with me and bearing with me doing live coding on my back. So, thank you. I wish you to have projects modularized in that way. And I wish you a great conference. Thank you. And see you at the after party.